Welcome to the next session of Finite Element Analysis. In this session, I am solving a numerical of beam element. This is question 17 of Direct Application of E.M.E. Using directly the E.M.E. for beam element, analyze the beam shown in the figure below. Here the length of 5 meters is given to me. It is marked here as H. One side is fixed, the other end has a hinge, and here I can see a UDL. On this portion of the beam there is no load. Here the load is F0, which is given as 1 kilonewton per meter, which can also be written as 1 Newton per mm. The two beam is made of material whose value of E is given as 2 into 10 raised to 5 Newton per mm square, and a cross section is given, so I1 and I2 is also given to me. Now we will start with the first step, which is discretization. I will be drawing this beam but as a line diagram. So I'll draw a straight line. Here I have UDL on the second portion of the beam. The length is H and H. Now here on this end I am going to mark node 1. Here I'll mark node 2 and here I'll mark node 3. This much is element 1 and this is element 2. Now for beam element, like your truss element, you are going to have 2 degrees of freedom at each node. So at node 1 I'll mark 1, 2, at node 2 I'll mark 3, 4, and at node 3 I'll mark 5, 6. So total there are 6 degrees of freedom in the beam. Next step is development of EME. The EME is given as 2EI upon HE cube. Now here again I am going to draw cross sign. I will have 4, 4, 4 and 4 elements at each position. So here the element is 6, 3HE, 3HE and 2HE square. Now whatever I have written here, I will copy the same elements here. So I will get 6, 3HE, 3HE and 2HE square. Now here the elements are 6, 3HE, 3HE and only HE square. So the difference here is 2HE and HE. So here again I will copy the same element 6, 3HE, 3HE and HE square. Now there are some negative signs also over here. Now I am giving you a trick for remembering as to where you will be placing the negative sign. For this EME of UDL, the negative sign is always on the first row and the first column. So I'll start with the first element. This will take a negative sign. This element will take a negative sign. This element will take a negative sign. And this element will take a negative sign. Now I have taken negative sign for all of them. Okay, let me write here for your understanding. I'll be also writing a negative sign for each element of the column. So this will take a negative. So it is already negative. Another negative is going to make it positive. This is negative, negative and negative. So the first row and first column elements are going to take up negative sign. This is how you can remember. After that, here I'll have W1, W2, W3, W4 raised to E is equal to FHE by 12. Then again I am going to have 4 elements 6 HE, 6 HE. The negative sign is on the second element. This is something that you have to remember. Plus I'll have Q1, Q2, Q3, Q4 raised to E. Now here you will have to remember that for W I will have 2 different sets of numbers. One is odd, one is even. Because when you see here there is 1, 3, 5, 2, 4, 6. So I have written 1, 3, 5. These values of W for 1, 3, 5 is going to indicate deflection. And 2, 4, 6 will indicate slope. Same way when I talk about Q, there will be 1, 3, 5 and 2, 4, 6. Two different sets of numbers. This will indicate shear force and this will indicate bending moment. So this is how you can just remember that what do these numbers indicate in the final GME. Because when you write EME, you will always be writing like this: W1, W2, W3, W4 raised to 1 or 2 or 3, how many soever number of elements you have. But when you write the GME, at that time you will have to write down for odd and even numbers. So you can just remember using this kind of a technique. Now I will be writing for element 1. For element 1, this will be 2 into, the value of E is 2 into 10 raised to 5 upon the value of HE is 5 meter, which means it is 5000 whole cube, and also there will be I here. For the first one it is 2 into 10 raised to 7. This is the value of 2 EI upon HE cube. So when I solve this, I will get the answer as 64 Newton per mm. Now let me just calculate 2 EI upon HE cube separately, because when I write this one, it will be too lengthy to write and the space will be required and you will be just shifting on to new pages. So I am just writing this value. Now this can also be written as 64 kilonewton per meter. I will be solving this numerical in terms of meter, because if you observe this matrix, if I write HE as 5000, the number will become too big and difficult for me to solve. So I will be preferably solving this numerical in meter. If you want to, you can solve it in mm as well. So I am leaving every value in kilonewton and meter. Now let me substitute these values here. So therefore I will get 64 as a number. Inside I will have 6, 3 and HE is 5, so minus 15. Then I will have minus 15 and 50. I will be copying these numbers over here: 6, 15, 15, 50. I am not going to take up the sign. Again the number here is 6, 15, 15, 25. Whatever I write here, I will be copying here: 6, 15, 15 and 25. Now all these elements are negative. Then I have over here W1, W2, W3, W4 raised to 1 is equal to, my next calculation is FHE upon 12. When you look at the first element here, there is no load. So I can see the value of F is 0. In that case, this entire number will become 0. Hence, I am not writing this matrix for the first element. I will be writing this for the second element, because here there is a load given. So I will be writing the last term over here, that is Q1, Q2, Q3, Q4 raised to 1. Now I am not going to multiply the 64 inside. I will tell you why when I form the GME. Right now we leave it to this, and I am going to only mark the degree of freedom over here. The first element has 1, 2, 3, 4 as a degree of freedom, because it is between node 1 and 2. So here I will write down 1, 2, 3, 4, 1, 2, 3, 4. Next I will go for element 2. I will be calculating 2 EI upon HE cube. This is 2 into 10 raised to 5. I is 1 into 10 raised to 7 and HE is again 5000 cube. When I solve this, I get 32 Newton per mm, which is also 32 kilonewton per meter. So let's substitute. I get 32, and this entire table over here is going to remain same, because I am going to only use HE, and this doesn't change for both the elements. So I'll just copy this here quickly. Here I'll write raised to 2 is equal to, for the second element, when I have to write FHE by 12, the value of F for the second element is given as 1. Since it is in the downward direction, I'll take a negative sign. So this value will be minus 1 into HE is 5 upon 12, and the bracket is 6 minus HE, 6 HE. Then I'll have plus Q1, Q2, Q3, Q4 raised to 2. Now here if you observe, the first element had 64 outside and the second element has 32 outside. So now either I can have 32 outside or 64 outside. Now what I can do is I can just leave this to 32, because here if I multiply with 2, which will make it 64, and I divide inside by 2, these numbers will become difficult for me to handle. Instead, here if I make this as 32 by dividing, and inside I just have to multiply. So while writing GME, I'm going to write this as 32 and I'm just going to multiply each number with 2. Right now I'm leaving it to whatever it is, and this number I'm going to multiply. So this will make it 32. So this will be minus 5 by 2 for the first one. Second will be 25 by 12. Third will be minus 5 by 2. And fourth will be minus 25 by 12. Plus, I'll copy this one. Now element 2 is between node 2 and 3. The degree of freedom is 3, 4, 5, 6. So I'll write here 3, 4, 5, 6, 3, 4, 5, 6. Next step is development of GME. I'll take 32 outside. I'll have 6 nodes. Here I'll have W1, W2, W3, W4, W5 and W6 is equal to, here I'll have a bracket, plus I'll have a last bracket as Q1, Q2, Q3, Q4, Q5, Q6. So I'll start placing these elements. First element is between 1, 2, 3, 4. I'll make this 32. So divide by 2, and this has to be multiplied by 2. So I'll just multiply each element with 2 and I'll place at 1, 2, 3, 4. So this becomes, so this is the first element that I've placed. Second element, I'm just going to copy these numbers and I'll place them at 3, 4, 5, 6. So I'll start placing from here 3, 4, 5, 6. The remaining elements will be 0. Now here I need to place the elements. So I'll go back to my matrix. For element 1, this entire matrix was not there. So I can just say that it is nothing but 0. So 1, 2, 3, 4, these are the positions where I should have 0. Now if you observe carefully, this is also 1, 2, 3, 4. So I have 0, 0, 0, 0 from the first element. When I go to the second element, I can see this is at position 3, 4, 5, 6. So I'll be placing these values here at 3, 4, 5, 6. So I'll have minus 5 by 2 plus 25 by 12, minus 5 by 2 and minus 25 by 12. Next I'll go for step 4, that is applying of boundary conditions. These are the variables that I have. Here W1, 3 and 5, these 3 will indicate deflection. 2, 4 and 6 will indicate slope. Similarly here 1, 3 and 5 will indicate shear force. 2, 4 and 6 will indicate bending moment. You can see the figure here. At node 1 there is fixed, at node 3 there is hinge. Now I'll just give you a simple trick which you can remember. This will help you solve the problem of beam analysis very simply. When you have a fixed at a particular node, the deflection and slope both at that node will be 0. When you talk about a hinge or a roller, any one of the two, deflection will be 0 because at that point you cannot have a deformation in the y direction, and the bending moment at that point is 0. So these are some boundary conditions which you can use. This will be faster if you remember this, and it will be helpful in solving the numerical. So when I go to the first node, now here deflection and slope both will be 0 because it is fixed. When I go to the third node, since it is hinge given to me, my deflection will be 0 and the bending moment, that is Q value, Q6 will be 0. So let's quickly write down the boundary conditions now. Here I write down W1 is 0, W2 is 0 because my node 1 is fixed. Next I'll go to node 3 which is here, 5 and 6. Deflection is 0 and bending moment is 0. Here I'll write down node 3 is hinge. Now by using FEA rules, look how quickly I can fill it up. These two are 0, so the ones in front of them have to be question mark. This is 0, this is question mark, this is 0, so this will be question mark. Since it's a 6 by 6 matrix, I can afford only 6 unknown. 1, 2, 3, 4. 4 unknown are done. Now these two I'll have to take question mark because I cannot assume these two as 0, but I can assume these two as 0, and this I'll be writing as balancing of secondary variables. So this is done now. I'll go back to the matrix. My W1 is 0. So I'll be neglecting the first row, first column for some time. My W2 is also 0. So neglecting second row and second column for some time. And W5 is 0. So neglecting the fifth row and the fifth column for some time. So whatever remains, I'm going to write the equation with that. I'll have 32 outside. 18, 15 minus 15. Here I have W3, W4 and W6 as the unknown is equal to minus 5 by 2, 25 by 12 and minus 25 by 12. Plus here I have 0, 0, 0. So let's write the equations now. When I solve these three simultaneously, I'll get the value of W3, W4 and W6. I get W3 as minus 0.01157 meter, W4 as 2.604 into 10 raised to minus 3 radian. Now if you observe carefully, this is deflection because it's an odd number and these two are slope. This is at node 2 and this is at node 3. Next I'll write the equations for calculating Q1, Q2 and Q5. I have 32. I get Q1 as 1.94 kilonewton. First value, so this is shear force at node 1. Next I have 32. I get Q2 as minus 6.939 kilonewton meter. This is bending moment at node 1. Next I have, note this equation, here a minus 5 by 2 is also there. Therefore I get Q5 as 3.05 kilonewton. This is shear force. This is at node 3. Now next I am going to go for my check step. I need to know if the answers that I have got are correct. So I will be checking the summation of shear force. I will assume all the forces going upward as positive. Now I have Q1 plus Q3 plus Q5. This is 1.94 plus 0 plus 3.05, and I also have, if you see the diagram, here this is minus 1 and the distance is 5. So this load is also there. So I will take it as minus 5. When I solve this, I get approximately 0. Next I'll take up summation of moment is equal to 0. I'll assume clockwise moment as positive. Now the value of moment is very simply calculated. At node 1, I have moment Q2. This is one value. Then if I come here, the UDL is placed at half. So if you imagine over here, this is 5 meter and this is also 5 meter. This UDL will be placed at half, which means 2.5 from here, and this distance is 5. So 5 plus 2.5 will make it 7.5. So this load will turn clockwise with a distance of 7.5. And last at node 3, I had a shear force which was Q5 is 3.05. So this will turn anti-clockwise towards node 1. So I am taking the moment about node 1. I have minus 6.939 plus 5 into 7.5 and minus 3.05 into 10. When I solve this, I get approximately 0. Hence, I have checked my solution. So with this, I end the session. I hope you have understood the numerical. If you have any doubts, please write to me in the comment section. Don't forget to like, share and subscribe to my channel. Hit the bell icon for latest updates of my videos. See you in the next session with another numerical on beam analysis. Thank you.